All right, we're going to start today with 8.10, AP Calculus Curriculum, volume of disk method revolving around other axes. We're going to calculate volumes of solids of revolution using different integrals, and our essential knowledge today is that volumes of solids of revolution around any horizontal or vertical line of plane may be found using definite integrals with the disk method. We're going to start today talking about the geometry behind what we're doing. When we talk about this, let's take a function. Let's say we're going to do, let's use the function f of x equals x squared. Let's sketch the graph. And we know that's a parabola with its vertex at the origin. And what we learned to do before was to rotate that around the x-axis to create a disk that we would then pull out. And we would find the volume of that one disk, and we would integrate, because there's an infinite number of those disks, as we would go from our lower limit of integration to our upper limit of integration. But in these cases, we may be asked instead to rotate around a line y equals 5. So in this case, probably need to draw a little lower, but in this case, our rectangle would be here, and the solid that we would generate, the disk that we would generate, would go rotating about that. And so we're going to have to find another way to express that radius of that disk, because when we pull that one disk out and draw it, the radius, what we're looking for, is the height of this rectangle. And so that's where we need to understand the geometry where we're coming from. We still have dx as our disk width, or the height, and then the radius is what we're going to be looking for. And that's what we're going to learn how to do when we do these examples. In fact, what we're going to do, the height of this, since this height from the x-axis to the curve is x squared, then the height of this rectangle would be 5 minus x squared. That would be this distance from the line y equals 5 to the curve. So the radius here would be 5 minus x squared. And then we could write the volume as pi times the radius squared times the height of that cylinder. If we were going to do this with a y, on the y-axis, let's see. Let's do an example with a y. Let's say that we were going to, let's use f of x equals x squared. Still, we have the parabola. This time, let's revolve this around the line x equals 2. And so let's take this region and revolve it around the line x equals 2. If we revolve it around that line, that vertical line, then we're creating this horizontal cross section. And we're going to have to figure out a way to get the distance for that radius again. So like we did before, we're going to solve this for x, and we're going to get y equals x squared. Oops. Then we solve that, we get x equals, and since we would be flipping this across the line y equals x, we would end up with the region in there. This would be our y-axis. And so x equals 2 would be here. And so now this would be the region that we'd be looking for. And that region would be rotating about the line x equals 2. So we'd end up with a disk that looked like this with height dy this time because we're perpendicular to the y-axis. And the height here would be x equals 2 minus, and this would be the square root of y. So the radius of this disk would be 2 minus the square root of y. If we wanted the volume of that disk, that would be pi times the radius squared times the height of the disk. That would be dy. Then we'd integrate that from y equals 0 to whatever y value is the intersection here. Should be 4. Yes, 4. And that's how we would do this. So we'll do some examples on the next videos.